Greetings, welcome all. Eric, would you like to start by introducing yourself since I'm doing most of the talking anyway?
Sure. I'm Eric Myers. I'm the treasurer for the Mid-Hudson Astronomical Association, and I will be driving some software called Stellarium that is used in planetariums like the one at SUNY New Paltz. And tonight we're going to just have it on your screen. And we should also introduce Steve Dittmar, another club member, who's going to be on the chat so that answering questions that can be answered by chat or saving them up for when we want to take some questions. Steve? Back to you, Jack.
All right, thank you very much. I'm Jack Chastain. I'm the current president of Mid-Hudson Astronomical Association, and very pleased to join the Walkway this evening for this presentation. We love doing this, and we really miss being actually physically out on the Walkway, which we have done quite a bit in the past. So this is the next best thing. It's not perfect, but it does work, and it gives us a chance to see some things that we can't see when we're out there in person. So what we'll do is we'll go ahead and start. And Eric, if you could go ahead and fire up Stellarium and get it out to everybody. Some of you may have attended the earlier Walkway Stars at Night, I believe it's about 6 months ago, the presentation where we showed some of the prominent constellations visible from the Walkway. Tonight we'll see a different sky and more constellations and a few special items. It's different because in the time since our last talk, our planet Earth has moved through about half of its orbit around the sun, which means that the dark side of our planet now points to an area that was 6 months ago pointing towards the sun. This is why certain constellations and stars only appear at certain times of the year, while others can be seen at other times of the year, but in different positions. So a note before we start, I will be using primarily Western concepts and views for most of the things we see tonight. I know there are many different cultures and stories about what we see in the sky. I am most familiar with those of the West, and although I know a little bit about the way other cultures see objects in the sky, I'm not familiar enough to be meaningful. So please excuse my Western-centric methods. There are many stories in the sky, and I leave it to you to find out some of the different ways that different cultures view the sky. Having said that, it's interesting to me that most of the names for the stars that we use in the West are Arabic. The stars were immensely important to the Islamic cultures, and the work in that area of the world has given us many of the names you will hear tonight. If you happen to speak any Arabic dialect, I hope you won't mind that I am going to butcher some of those pronunciations, but that's where it goes. So we'll begin our tour of the sky tonight by looking at the nearly current night sky. This is what we will see. Actually, you'll notice that Stellarium is actually showing us, it looks like a picture of the Walkway. That's thanks to Eric and his work. We can embed images in Stellarium. But we're going to take a look then a few days into the future so that we can show you an event that will not repeat for at least 20 more years, and really not this good at all until 2080. We're using a wonderful bit of software that Eric mentioned called Stellarium. It allows us to move forward or backward in time and even change locations. So we're going to watch the sun set at a slightly higher rate of speed here. It actually will happen. Actually, out here it looks pretty dark, so it must have already set. But anyway, we'll let Stellarium speed time up for us. If we look down at the little box at the bottom of the screen, we'll see a time going by very quickly. That's what tells us where we are. Eric may also bring up another box that gives us a different view of that. But in any case, we're going to move forward until about 4:35, and
we're at 4:42.
As we watch the sun set, we're going to look for a small light to the left of the sun, just starting to show up. And it shows up around here locally about 4:45. You might have to wait a little bit longer for the lights in the sky. But this is the large planet Jupiter. Let's zoom in and take a look at it. In a good binoculars or a telescope, we can easily see several of Jupiter's moons. We'll talk about those again in just a second. You can notice the
And,
moons to the
Jack,
left
just
and
to
right.
interrupt you, Jack, I just want to make sure everybody can hear you. There is someone that has a hard time with audio. So
Is the audio okay?
Yep,
Does it
okay,
need to be
thank you.
louder?
Yep, I think we got a couple yeses, so you're good to go.
Okay, dynamite. I can probably up it if I need to. Anyway, we can see Jupiter and at least 4 of its moons right now. These are known as the Galilean moons. Ganymede is to the upper left. Io, Europa, and Callisto are down to the lower right. Taking a close look at the moment at those Galilean moons, they were so called because Galileo first viewed them with his small telescope around this time, early December in 1609, 400 years ago. These moons are easily seen to change positions as they orbit Jupiter. You can watch them for a time almost any night and see them change positions relative to each other. They were the first indicators that all of the things did not rotate around our Earth, and they began the understanding that our galaxy and universe were different than the first attempts at understanding it, positioning the Earth at the center of everything. These moons are also the largest things in our solar system that are not the sun or the 8 planets. Ganymede is the largest moon in the solar system, and it's actually larger than the planet Mercury. But Jupiter is not alone tonight. To the upper left of Jupiter is our second largest planet, Saturn. It should be easily visible tonight shortly after 5 p.m. or so, when it starts to get truly dark. Tonight, these two are nearly 1 degree apart. That's about twice the size of the full moon, but things are changing with them. Over the next several days, they will appear to get closer each night until on the 21st, when they will be very close. Visually, they may appear to be almost touching, though they remain many millions of miles apart. Let's move forward in time from tonight to the 21st. Eric will move forward to the 13th. He's on the 13th now. Let's do a little rearranging in position. And we will move forward to the 14th. And this is on the 15th, on the 16th, on the 17th, 18th, 19th, 20th, and then finally on the 21st. Looks like there's one planet there. Saturn is now just to the right of Jupiter by the tiniest little amount, about 1/10 of 1 degree of arc, or less than 1/4 the size of the full moon. In fact, on the 21st, the moon will be in the first quarter, showing only half of the moon. The full moon is roughly 1/2 of 1 degree of arc. So the visible part on the 21st would be about 1/4 of 1 degree of arc. Well, the planets, as we see them on the 21st, will be separated by less than half of that distance. So this is going to be very close. This is known as a conjunction, and when 2 notable objects appear close together in the sky. Because this particular conjunction is between 2 of the largest planets in our solar system, we call it a great conjunction. The way orbits work, especially with regards to Jupiter and Saturn, they appear to be close to one another in the sky every 20 years. Back in 2000, they were about 8 degrees apart, but the conjunction appeared to be very near the sun. And aside from being not really visible because they were so close to the sun, this isn't really a notable conjunction at all. That's 8 degrees is 16 times the size of the full moon. So although they approached each other, they didn't really look like they were that close. To get one like this, and presuming that you were around to see it, you'd have to go back to the year 1226. So if you can, try to find both Jupiter and Saturn over the next several nights, before and after the 21st, assuming the clouds allow us to do that. They will appear just after sunset, but they're going to get closer to the sun. So there's going to be a time when they're just too bright to see them any further before they set. But you should be able to see it easily for the next several weeks. Watch the positions change relative to each other each night. You should be able to see them easily converge, and after the 21st, diverge again. It should provide quite a nice sight for the next several weeks. Also, you might want to put January 10th on your calendar. If you're careful and you're lucky, you might be able to see Saturn, Jupiter, and Mercury all together in the sky after sunset, about 5:15. Mercury is very hard to see though, but it is possible. So what we're going to do is we're going to move time forward to the 10th here. We're currently at the 25th, and we're going to keep going forward. That's the 30th. You'll see the two planets diverging, and then we have to arrange our time to get them sort of back up above the horizon just a little bit. We'll see the sun come in. And just a moment here, we should be able to, there we go, backing it up. And what we're going to see is we're going to start seeing Mercury come in to the picture. Again, we're stepping forward by days. There's Mercury. We're going to go one more day to the 10th. And there we have a nice little triangle formed by Mercury and Saturn just above the horizon, and about the same level, and Jupiter just above Mercury, forming a peak of a little bitty triangle. Now, be very careful when looking at this, because Mercury never strays terribly far from the sun. So you don't want to be looking at the sun, and especially not if you have any kind of telescope or binoculars or any other magnifying object. If you know what you're doing, it's dangerous, but usually fairly easy to accomplish. However, if you don't, you do not want to be looking at the sun with anything at all that magnifies it in any way. We can do it safely with software, so it just is going to show you the position. Mercury is also, although it appears in this image to be just about as bright as Jupiter, it tends to be very, very dim planet. All righty. So now we're going to return to tonight's sky for the rest of the presentation. Pulling away from the conjunction and getting rid of our atmosphere, I wish we could do that in real life, and looking due west, we can see the band of the Milky Way. That is our own galaxy, and it extends just a little bit south of the west end of the Walkway. In a relatively light polluted sky of the Poughkeepsie area, it might be hard to see, but it is possible. You may have to wait till a little bit later though. So facing the west end of the Walkway again, look for the three bright stars that form a triangle just over the end of the Walkway. These stars are Altair, Vega, and Deneb. In the order from the lowest to the highest, again, they're Altair, Vega, and Deneb. We did that already. These are 3 of the 20 brightest stars in our night sky, and they should be visible easily, even with the lights of Poughkeepsie Island. In order of brightness, Vega is the most bright, at the 5th brightest in the sky. Altair is the 13th brightest, and Deneb is the 20th brightest. But here's an interesting thing. Although Vega and Altair are both about 20 light years away from Earth and about the same brightness, Deneb is over 1,400 light years away. This tells us that Deneb is far larger and brighter than the others. It's known as a supergiant and will eventually end its life in a supernova. That's a long way away though. These stars are also the brightest stars in each of their associated constellations. Altair is the brightest star in Aquila, the Eagle. And Vega, oops, there we go, there's Altair. Vega is the brightest star in Lyra, the lyre or harp. And Deneb is the brightest star in Cygnus, the swan. And you notice that Stellarium allows us to give some of the imagery that people imagined in the sky. Now, each of these constellations holds some interesting views through a telescope, but two of them are really the most interesting, at least to me. These are the Ring Nebula in Lyra and the double star Alberio at the head of Cygnus. Both are relatively easy to find. Let's start with Alberio. Cygnus appears to be flying along the Milky Way. At this time of the year, it's flying down. So with Deneb marking the tail of the swan, we can see the long neck pointing downward, the wings to the east and the west. Move down to the dim star that marks the head of the swan, and this is Alberio. With a telescope, looking at this star, we actually see its two stars with interesting qualities. One of the strange things people ask me is we want to look at a star. Most astronomers really don't care much for looking at stars, but Deneb is different. As we zoom in, we can get to a position where we imitate with the software looking at the star through a good telescope. And we should be able to see as we get closer and closer. Let's get in there. There we come. Going to shift to our ocular view here in a minute, maybe. There we go. We can see now that there's two stars. It's a little difficult to see on the screen, at least for me. In a telescope, it's incredibly obvious that the little star up above the bright big one is very blue, and the larger star below it is very gold or yellow. They actually do look beautifully blue and gold in a telescope. They're wonderful to look at. The blueness indicates that the smaller of the two is a much hotter star than the larger. All right, so we'll zoom back out to a more normal view here, more like we're standing at the walkway looking. And the next object we'll look at is a slightly more difficult object known as a deep sky object, or DSO. This is an object that is not necessarily a true star. And we'll try to locate it. We'll try to find the Ring Nebula in Lyra. Alberio was visible to the naked eye, but the Ring Nebula is not. So we have to know how to find it. We look at the constellation Lyra. We know it consists of the bright star Vega, and there's 4 stars, very easy constellation. There's 4 stars that make up almost a perfect parallelogram. 2 at the top near Vega and 2 at the bottom. The Ring Nebula is located near the center of a line between the bottom 2 stars of the constellation. These 2 stars are named Sulafat and Sheliak. So if we were to imagine a line between those 2 stars, and we were to go slightly closer to the bottom one than the top one, but right in the middle there, just about there, we'll start to zoom in. We'll start to see something that doesn't look like a star. Let's see when we can stare. It's starting to show just that little spot on the screen. Notice that it's not a point. It's very small. You might need an 8-inch telescope to see it well, but when you get it in a telescope, it appears to be a nice tiny smoke ring. It's different from everything else you can see up there. This is a ring of gas and dust from a star that has died and puffed off its outer atmosphere. This is not a nova. It's just the way a more normal star like our sun dies. The ring is about a light year across, and it's 2,567 light years approximately from us. In about 5 billion years, our sun is going to do much the same thing. But to the eye in a telescope, it looks like a faint gray ring. But when you add time through astrophotography, you can get images like this striking one. Just beautiful. That little star in the center is thought to be its original star that's now becoming a white dwarf. All right, let's go back to a more normal view. And we'll start to swing to the north and look down at the horizon just above the river. Depending upon exactly when you spot it, we'll see the very identifiable arm and large bowl of the Big Dipper, which is not a constellation, but an asterism, or part of a constellation. Constellation of Ursa Major, the Big Bear. So we have the end star is Alkaid. And if we move into the second star in from the handle, which is Mizar, we might be able to see, if you have good eyes, it's actually two stars there. It's a double star. It's what's referred to as a naked eye binary, meaning that you don't need equipment really to see that it's two stars. Legend holds that this star was used as a visual test for sailors and other folks, but it's not really that hard to make out the two stars, so we think that's kind of legend. The two stars are named Mizar and Alcor. I say Mizar because I had a ship of that name. I think it's more realistically called Mizar, but there we go. This familiar asterism is also commonly used to help us find our celestial North Pole. The pole star, Polaris, using the two stars at the far end of the bowl, which are Merak and Dub. I hope I said that close to right. We can use those as pointers. We move in a line 5 times the distance between those two stars. And at the end of that 5th element, we find Polaris, which is the star in the end of the handle of the smaller Little Dipper, or Ursa Minor. The Little Dipper is actually a constellation. Now, let's move to the east. We're going to look towards the east end of the Walkway, and slightly to the north of the east end, we're going to see 2 close and relatively bright stars. These are also 2 of the 25 brightest stars in the sky. Castor at the top is number 24, slightly dimmer than Pollux, number 17, below it. There we are. There's Pollux. These are the heads of Gemini, or the twins. And you may know Castor and Pollux as the 2 twins. Pollux is the brighter of the 2, but only by a little bit. And Pollux is also the closest giant star to the sun. It's about 34 light years away. Now, we're going to talk about meteor showers because there's one tonight. Meteor showers are periods of time when the Earth passes through, usually, the remains of comets that have passed near or through the path that the Earth takes on its trip around the sun. Tonight, December 13th, marks the peak period of one of the best and most recently identified and created showers called the Geminids. We call it this because regardless of where you see meteors in the sky, for the most part, if you drew a line back from the flash for all of them, they will generally appear to have come from just above the star Castor. And we're pointing out the orientation where that point would appear to come from. Since this is in the constellation of Gemini, we refer to this meteor shower as the Geminids. Now, I said that most meteor showers are caused by comets. They consist of tiny grains of sand or smaller dust particles hitting the atmosphere at great speed, burning up very brightly. The Geminids are a little different. And if the skies are clear, which I think there's a forecast they should be after we finish this talk, you definitely should go outside tonight no matter where you are and look. For one thing, the peak of activity is early. It's about 8 p.m. for us. You don't have to stay up as usual until about 2 a.m. for these things. And for another, this dust field was created by an asteroid, not a comet. It's a very large asteroid. It's over 3 miles in diameter. This asteroid gets very close to the sun. It cracks and melts its surface, which throws off much larger chunks. So this creates the opportunity for larger, bright fireballs during the shower. It's also nice that there's no moon, so we'll have the greatest opportunity to see even the smaller flashes. But even from our light polluted skies near Poughkeepsie, we should be able to see these bolides, these very, very bright flashes. So now, looking a little bit south of east from the end of the Walkway, we can also see 3 stars in an almost vertical line. This is the belt of the also very recognizable constellation Orion. Orion holds several more of the brightest stars in our sky. Rigel is seventh brightest. It's Orion's left leg. And Betelgeuse is number 10. I want to point out here there's 4 different ways to pronounce Betelgeuse. So pick one. It's the 10th brightest star in the sky, and it is Orion's right shoulder. Bellatrix is number 26, really the dimmest of the ones we'll talk about tonight, and it's Orion's left shoulder. Betelgeuse was recently noteworthy because it had dramatically dimmed. If you go out and look at it tonight, it's really bright. It's up there amongst its level of number 10th brightest star. But months ago, it had dimmed to, I don't know, well below its lowest normal value. It caused some people to think that it was about to go nova or explode. It is due to do that, but it seemed to be a little early. It actually seems that it just really blew out a large cloud of gas and dust. It happened to be between us and the star. So that dust dissipated and it's currently back to its normal bright self. Although it normally does change brightness anyway, just not as much as it did recently. So that was exciting. If you saw it, you might notice that it's brighter now than it was. Now, hanging from Orion's belt is the sword or scabbard. People usually think this is somewhere like 3 stars, but actually the middle one isn't so much as a star as a large cloud of gas known as a nebula. In this case, the Great Nebula of Orion. It is very visible and very pretty in a telescope. It's lit by several stars and is one of the brightest nebula visible from Earth. Roughly 1,350 light years away, it is also one of the closest star-forming regions to Earth. Just gorgeous. We're going to pull a little bit of a trick now. We're going to remove the ground because I want to show you a star that actually is the brightest in the sky. Number 1, Sirius, the dog star. It is the main star in Canis Major, the big dog, but unfortunately it doesn't rise for another hour or so. So rather than move time, we just remove the ground. Because Sirius is so bright, it will often appear to flash or twinkle a lot more than the other stars. Watching it for a few seconds, you might even swear it's man-made, but it doesn't move other than its normal flight through the sky over the night. So be sure if you're out a little later tonight that you look east and you try and spot that incredibly bright star of Sirius. All right, so to complete our journey around the sky tonight, we're going to continue to the south and slightly to the west. We're going to look high up, a little bit more than 45 degrees, about halfway between the ground and straight up. And we should find a bright orange object. And if you look closely, you'll see that this is not twinkling like the other stars. This is a telltale mark of a planet. And of course, this is Mars. Bright and just off of its closest approach to Earth 2 months ago on October 13, when it was only 39 million miles away from us. So tonight we have no moon. The moon is currently located very, very close to the sun, and we refer to this as a new moon. It's going to actually start to show as a slim crescent in a few days, around the 16th or perhaps. So we're going to see if we can do a little time dance here again. And watching Mars, we're going to see if we can pull around. Actually, we should be watching Jupiter and Saturn. There we go. We're going to move forward to the 16th around 5:45 in the afternoon. And when we do that, we should start to see there's the 15th, there's the 16th, and here comes the moon. Just below the site of Jupiter and Saturn, growing ever closer, almost perfectly below the 2 giant planets when it sets just after 6 p.m. on Wednesday. The next day, Thursday, you're going to clearly see the moon as a very small crescent, now well to the left and slightly above the two planets. Let's go one further day forward, I think. There we go, and there it is up there. That should be a very visible, very slight crescent. That's going to be a gorgeous view with this moon sitting there right next to the two big planets. So you should definitely go outside and look for that, as long as we don't have clouds. Tomorrow, the moon is going to be directly in front of the sun, though, and a total eclipse will be visible from South America. We're not going to see a thing here, but you can watch it live on the web, thanks to the magic of the web. And I'm going to place an address in the chat for a total eclipse viewing site, one of probably many. And if you go to that site early in the morning, the eclipse is going to occur at 8:33 a.m. our time. You should probably get on that site a bit earlier than that, perhaps 8:15 or so. But the eclipse, if you've never seen one, it is amazing. It is just absolutely amazing. It takes about an hour. Let me think about that for a second. No, it's got to take less than that. I don't remember exactly how long it takes for the moon to move in front of the sun, but it takes a period of time. And so you will be able, hopefully, to see on that site the moon slowly come in, cover the sun, and eventually do a complete coverage and see the lovely corona and lots of the other goodies there and the darkness around it. It's just amazing. If you have a chance to see it in person, we have one that will be not too far away from us here. It's going to strike through the upper part of New York in 2027, Eric? I forget exactly the year.
2024.
24, that's it. Thank you. So 4 more years in April. I think Rochester is fairly near the center, but if you have a chance, definitely see it. So the evening of the conjunction on the 21st, next Monday, the moon is going to be, I think I mentioned, a first quarter moon. This is an excellent time to view our closest astronomical neighbor. That was in the days before it becomes a quarter moon. Through a telescope, having a partial lighting increases the contrast on the craters, and other features really stand out. Be sure to carefully look just inside the dark area. We call that line the terminator. And if you go just into the shadow from there, you may be able to see through a telescope little points of light. And this is the sun hitting the tops of particularly tall craters. Looks like jewels to me. It's just lovely to look at. It's much nicer to look at the sun, the moon in this phase than it is when it's much more full, because you lose the contrast. So tonight we have seen an upcoming grand conjunction, some of the brightest stars in our sky, one of the best meteor showers available, possibly very soon, just an hour away from peak, and even possibly a total solar eclipse. There's a lot that we haven't talked about in the sky, though, and I hope you'll take some time to look up and find out about some of the other things up there, things that we don't see with our eyes normally, and things that we do. MHAA holds a roughly monthly star party at Lake Taconic State Park. Weather permitting, we pick the closest Friday to a new moon and bring telescopes for everyone's viewing pleasure. Of course, this means that our most recent one was just this past Friday. But we do this year round, and you can find our schedule at our website, which I will also place in the chat window. Like so. We usually have plenty of telescopes, and some of the scopes may be equipped with special filters that allow you to see things that you don't normally see. It's free, and you don't have to bring your own telescope. Sign up on our meetup page, which is the same link in the chat, midhudsonastro.org, and join us. But please wear masks and dress for the weather. And the park does require us to get your vehicle license plate and your car make and model. That's not us, that's the park. And give us that and show up, and that's all there is to it. So that finishes what I have for you tonight. I'd love to take any questions if you have them.
Okay.
Were there any in the chat, Steve, while I was running on?
Yeah.
Yeah, there was one that maybe you or Eric would know. This last one that was just asked by Jim Edwards. He was wondering if you've used the Stellarium Mobile App and if you have any opinion on that. And my understanding from what I recall is the Stellarium software is, like, the code base is open source, and that they don't necessarily have an official app from Stellarium themselves, but there's a couple variations that use that code. But I don't have personal experience with them. Do you guys?
That I do. I use it all the time. I think several of us do, and that is absolutely correct. They are very similar. The Stellarium mobile app is excellent. If I had a single complaint about it, it would be that I don't think they understand what to charge for it. I have seen prices for the mobile app range from $3 to $25, and it kind of depends on what day you hit them. But I certainly bought it. It's very useful to me. It gives you, I would say, probably 75%, maybe 80% of the features that you have in the full Stellarium on the desktop. Quite useful. I did try to use it out at the Star Party this last Friday to locate Cygnus X1, which is our first known black hole identified in Cygnus. The computer had it, but the mobile app did not. So it's not entirely the same, but it is very, very close. And of course, the mobile app offers you something the computer does not have, which is the follow the position of your cell phone ability. So you can turn on the function in the cell phone. You can wave your cell phone around at the sky, and it will show you on the screen what it is you're looking at, as long as your sensors are all aligned. So I love it. It's one of the apps that I have on my phone, and I definitely advise you to get it.
Okay.
We have, is Titan the second largest moon? I don't know the answer to that right off the bat. Do you, Eric or Steve?
I think it's Ganymede, then Titan, then Callisto, I think.
Very possible. And Titan, of course, is a moon of Saturn, right?
Yes.
Yes.
Yep.
Yes.
Yeah, Ganymede would be Jupiter, Titan, Saturn, Callisto would be Jupiter, and I think Io is right after that as well, which is also Jupiter.
Of course, the Galilean moons are the largest of the closest of the largest planet. So the Jupiter is the closest massively large planet. Saturn is the next largest planet, but further out. And that gives the Jupiter's moons a little bit of an edge visibly for us. And when Galileo looked at them, they were obvious to him. And that's one of the things that sort of got him into trouble.
I see Chris asked the difference between moons and planets. And I guess I believe the general definition is that the planets orbit a star, whereas the moons orbit an object. Is that, would you define it differently, Jack?
That sounds good to me.
Okay.
Nope, that's it.
And one of the Ish is on. He's one of our former lecturers. So Ish, we're up for a repeat as well from you. When you visit the Walkway YouTube channel, you'll see this presentation, the May presentation, as well as other of our presenters like Ish, who's on the line here. So that's great.
Okay.
Steve, did you see any other questions on there?
Yeah, I'd see one from, let's see, where was it? Lisa asked if she heard correctly that Jupiter has 4 moons larger than Pluto. I do believe that's accurate.
We did say that one of them was larger than Mercury, and I believe that I know that I think isn't the moon, our moon, larger than Pluto?
It may well be.
I believe I knew that. So I don't find that to be a problem at all. I think that that's probably correct.
I think I've heard that as well.
I don't know it for a fact, but it sounds right.
Right. April asked earlier, you mentioned that the Swan's upside down next to the Milky Way right now, and asked if it's always near the Milky Way or and just changes its orientation.
With the caveat that you can only catch it really if with some really serious measuring equipment. Every star is, for our intents and purposes, fixed in the sky. Only the planets, which is of course what the word means, it means wanderer, only the planets will change their position. So all of the stars will remain very, very, very close to exactly where you see them now. However, throughout the year, our position changes with respect to the sky. So the swan, in this case, Cygnus, will appear at different times of the year to be oriented slightly. I think during the summer, it appears to be flying across the sky, but it is always right where it is, and the Milky Way is always there. It's always flying through the Milky Way. It's just that right now it looks like it's headed down. Other times of the year, it looks like it's across or a little more up. But it's always, relative to the stars that it's around, it's always the same.
So Ish asked where the moon, where Earth's moon ranks in size, and I believe that's number 5, right after Io.
It could,
So
yeah.
Those 3 Jupiter moons you mentioned before, plus Titan, the Saturn moon, and then planet Earth's moon is, I believe, number 5.
Yes, we have an unusual moon.
Yeah, it's large for our size of our planet.
Right. We mentioned that Jupiter has very large moons, and that they're probably close in size to ours, but Jupiter is much larger than the Earth. I don't remember the exact number. Is it like 10 Earth diameters, something like that? I don't want to say that as a fact because it's not a item I have in my head right now. But Jupiter is very much larger than the Earth, and yet its moons are about the same size as ours. So our moon is unique in a couple of ways. It's unique in that it's very large for the planet that it orbits, us. And it's also interestingly unique in that it also happens to be the same angular diameter to us as the sun is. So both the sun, yes, within human differences. And it also, that angular difference does change slightly because of the way the moon orbits. But for the most part, it's the same angular size as the sun, which is what allows us to have a total solar eclipse.
And also worth noting too, the moon is slowly moving away from us. So we're in a particularly interesting time frame of the planetary life cycle, in that it is at that exact distance for us to see that particular phenomenon.
Exactly. A couple of thousand years from now, it's just going to make a donut out of the sun.
Right.
So
very good. Lena asked if there were any moons with water on them. I know there's like 4 or 5. I think some of the I think Titan and some of the Jupiter moons, they've kind of sensed some water. But our even more recently on our own moon as well.
Yeah. Yes, quite a few. And then what is the what's the moon covered in ocean? Oh gosh, it's not coming to me. That's not Europa, is it?
Forgetting which one it was too.
One that is, it was a very bright moon, and they were kind of curious about that. When we finally got a satellite up there, we found it was covered with ice. And it apparently is entirely covered with frozen water on the surface. It has water volcanoes that we've been able to image. And the theory is that there's quite a depth of liquid water below that ice.
Yeah, I believe it's Europa. I think that has those big tiger scratch looking marks on it that they think are the cracks in the ice. Yeah.
Yeah, I'm biased there because the only thing I can think of is 2001 or 2010, I guess, at that stage. All these worlds are yours, save Europa.
Right.
Because that was the one with water on it.
Yep.
Anyway, you have to read Arthur Clarke for that.
So Bob Toop had a question, or sorry, not Bob Toop. Bob Nasser had a question. He asked if you could repeat where in the sky the meteor shower can be seen.
Sure. Where in the sky the meteor shower can be seen. Is that okay? No, I'm sorry. I'm being silly. The meteor shower can be seen any place in the sky. The trick with calling it the Geminids is when you see several of these streaks, regardless of where you see them in the sky, if you take them, they will streak across, let's just say from your right to your left. Well, if you went backwards and followed that line back, you would find that it approached just above Castor in the Gemini constellation. So we refer to them as the Geminids. That doesn't mean you have to be looking at Gemini in order to see them. Look, basically, the best thing to do is to get a nice easy chair, chase lounge, something, blanket, lots of covers. Just lay down on the ground and look straight up, because they can appear any place in the sky.
So the term that this area is called is the radiant for the
Correct.
for the meteor shower. They all appear to radiate out from that one point in the sky, but they're all over the sky. And Stellarium doesn't do it right. For if we see any tonight here in the software, they'll just be going in all different directions.
Yeah, and Stellarium just does that to imitate them. They're not obviously not real, because it can't predict where we're going to hit dust. But occasionally, as we watch this thing, you might see a little streak. And I bet you, Eric, if he pokes around a little bit, he could probably up the number a little bit, make it crazy. But Stellarium just tries to simulate the effect. It's not quite real, and in fact, it may or may not actually indicate the proper radiant for the Geminids. But the idea is that the Earth is moving through a cloud, and since that cloud is in a particular position in space, everything we hit is going to appear to come from basically the same spot, but it's not going to necessarily be close to that spot. Just look up.
Bob too pointed out that Enceladus, the moon on Saturn, is the other one that's very icy. Yeah, that's the super bright one that you're probably thinking of.
Thank you. Yes. Like I said, I'm biased when it comes to that. I can't get my brain out of that. It's like Mizar and Mizar,
And Charles asked what's a good telescope brand to suggest. And I would say, Charles, if you ping us on Facebook, and we can kind of help you if you want to try and figure out a telescope to start with. There's a handful of good brands out there for sure, but there's a wide variety in price and capability, and so it kind of depends a little bit on what exactly you're looking for it to do for you and who it's going to be for. If it's for a kid versus an adult, somebody that's willing to put in the effort to maybe set something up a little more, knowing that they'll get a better image out of it, versus something that's going to be real quick to just plop out there and the kid won't lose interest fast. So if you message us on Facebook, we can try and get you squared away with a good direction to go for you.
And we'll share that on our page when the video is ready. We'll send you. We'll also include the link to that Facebook page.
Excellent. Thank you so much.
So
I will also.
people,
I'm sorry, Tracy.
Go ahead, Jack.
I was going to say, I would also point out that there's a lot of different things to consider when you think about starting out with a telescope, and the star parties that we hold are an excellent way to gain some experience with different types of telescopes and get a feel for what you want. Having had experience lately with a few of these, I would definitely suggest strongly that people avoid computerized, what they call go-to scopes, especially as a beginner, because they can be nothing short of aggravation. But definitely get with us. We can talk you through some things, and we can even get you experience. And there's another side effect I didn't notice of actually becoming a member of our group, which isn't very expensive. But if you are a member, we have telescopes and other equipment that you can borrow. So if you don't feel like spending $2,000 for a telescope, spend $25 a year, join us, and we'll give you one.
For a little while.
For a little while.
We want it back because we want to share it with someone else.
And I just want to take a moment to introduce Elizabeth Waldstein, who's our executive director. So I see you down there, Elizabeth.
Or here. Yeah, I just wanted to say thank you as always. We miss seeing everybody out on the walkway looking at the stars, but we will be there soon. Hopefully this spring we'll be back. And Jack, I'm glad to hear you've been able to continue the star group meetings at Taconic, a little bit darker than the walkway, but One of the great things about our partnership for 9 years now has been exposing a lot of people to the idea of looking through a telescope, to even the concept of astronomy. And so I want to thank or you guys for, showing up month after month whenever the sky allowed us to. And, just everybody have a happy new year, happy holiday, stay safe. And, we look forward to seeing everybody in the spring.
Thank you. Thank you, Elizabeth. We did pencil in 2 a month for Walkway at Night starting in April of next year. So we'll send you those dates, Eric. And John Stork is our board chair, and he's joined us as well.
Good.
John.
Welcome, everybody. I'm very exciting. Yeah. I'm in Durham, North Carolina. I should have snuck a question in there. Will the meteors, you think they'll be visible from North Carolina this evening?
If you've got sky, yes, they will.
Okay,
So,
well,
It's the same sky.
Yes, exactly.
It's the same sky.
70 degrees today. It's actually really warm up here. So everybody take care.
Thank
Got
you.
some,
Thank you.
got some weather coming in the next 2 days.
Yeah.
Right. Yep.
Yeah.
All right. Well,
everybody.
great.
Thank you very
Again,
much.
if you visit us at walkway.org, and we also have our YouTube channel connected there and our Facebook pages, we will get this recording up there, and feel free to share it. So have a good evening, everyone. Thank you very much, Jack and Eric, and
Thank
the
you.
rest of the crew. When we see you up on the walkway, it will be a great day or night for us. So looking forward to that time.
Okay, thank you so much. Appreciate it.
Thank you. Thank you.
Everyone.